No section on quadratic functions would be complete without at least a few problems that involve some sort of object like a ball or a stone being thrown or kicked or hit into the air, because what goes up must come down, and gravity makes a quadratic or parabola shape. So this clip is all about how to handle those typical problems that involve a ball or a stone or some other object that's being launched up into the air and then it comes back down again. So let's take a look at an example problem. A football is punted into the air. Its height, h, in meters, after t seconds is given by h of t is equal to negative 5t squared plus 30t plus 1. And in A, we're asked to find the maximum height of the football. And then in part B, when does the football reach its maximum height? All right, so in this question we're dealing with a football, but keep in mind it works equally well, these steps, for a question where there's a golf ball or baseball or somebody's thrown a stone or any object that's put into the air and then falls back down again because of gravity. So let's get started with step 1. Since in part A we're being asked to find the maximum height of that ball, we're going to need to convert the height equation, which is given in standard form, into a form that allows us to look at the maximum height right away. So let's do that by completing the square. If you don't feel too confident with your skills on completing the square, check out an earlier clip on completing the square and it'll walk you through the steps that I'm going to show you here. But the first thing I'm going to do is common factor out the negative 5 from the first two terms. And that'll leave me with this, t squared minus 6t. And then I close the bracket and leave the plus 1 at the end. Next, I need to take half of the middle term. In other words, that negative 6. I need to take half of negative 6 and then square that. Half of negative 6 is negative 3, and negative 3 squared is negative 3 times negative 3, which makes plus 9. And then I write the minus 9 right beside it to make a strange looking 0 inside of the bracket, so it doesn't change my equation. Next, I want to pull the negative 9 outside of the bracket. So this negative 9, I want to write it over here, but before I can remove it from the bracket, the rules say I have to multiply it by whatever's in front. So I'll have t squared minus 6t. The plus 9 stays inside the bracket, and I have minus 9 times minus 5, which makes a positive 45. And I keep the plus 1 right where it was. And next, this quadratic inside the bracket is a perfect square quadratic. It's special because I can simplify it like this. I take the square root of the first term, t squared. Well, the square root of that is just t. I take the sign of the middle term, which is negative, and the square root of the last term. The square root of 9 is 3. And then I add a squared exponent right there. Plus 45 and plus 1, that just makes plus 46. And there you go. I've completed the square to transform my standard equation into this form. Now it's a lot more useful to look at. At this stage, I can do a common sense check. Since it's an object like a ball being thrown up into the air, in this case it's a football being punted into the air, it's going to go up and then come back down again, which means this number in front should be negative. If it's negative, that means my parabola opens downward, and that's the case here. So you should always get a negative in the front when you complete the square for an object like a ball being thrown into the air. Now the maximum height, which is what we need for part A, is just this number on the end. Let's say the max height is 46 meters. And that's my final answer. So remember that you need to take your height equation, if it's in standard form, as it was here, and using complete the square to convert it in this format here. And then we're going to read off the number on the end. Now let's answer part B. Don't let it fool you. Part B is actually quite simple. The maximum height is 46 meters, and it achieves that height whenever we have a 0 in this bracket. So what would t have to be to make a 0 in the bracket? Well, we can show that with a bit of algebra. We can just say t minus 3, whatever's in the bracket, and set it to 0. And we're going to move the minus 3 over to the other side. So that means that t has to be 3. And our units are seconds. And that's the final answer for part B. So remember, the maximum height is reached whenever there's a 0 in the bracket. In this case, it was 3 seconds. All right, so now it's your turn to practice. Grab your pencil and paper and try this problem. A golf ball is hit into the air. Its height, h, in meters after t seconds is given by h of t is equal to negative 5t squared plus 40t plus 0.6. And in A, find the maximum height of the ball. And then in B, when does the ball reach its maximum height? So try that using the same steps I showed you on the left. All right, for part A, we found the maximum height to be 80.6 meters, and we found that by completing the square. And in part B, we just looked inside this bracket to find that the t, or the time, had to be 4 seconds.